Hey everybody, so let's take a look at drawing and naming isomers a little bit more in depth, and let's take a little bit more challenging one. Let's look at octane and how we name it and how we can come up with the 18 isomers of octane. Okay, now let's see. So propane has 1, butane 2, pentane 5. Okay, I mean it goes, they gradually increase. Oh, I'm sorry, pentane has 3, hexane 5, and down the line. Okay, and then eventually it just takes off, and so octane has 18 isomers, and then nonane, and then decane, 10 carbons, C10H22 has 75 isomers, and then undecane, 11 carbons, C11H24. I mean, it goes up like ridiculously. But octane is a compound that we can probably handle, and so let's keep in mind that we're going to do C8H18. Okay, and so let's start with kind of the most straightforward one, where we draw the carbons 1, 2, 3, 4, 5, 6, 7, 8, and then the hydrogens. I'm actually going to leave the hydrogens off of this one just because drawing all the hydrogens there, that can be a pain in the neck. Okay, and so if we look at this, there's 8 carbons in a row. Okay, that's the longest carbon chain. It's the only one that there is, so I'm going to name this N-octane, the normal octane. Okay, now let's do this systematically. Let's have a system for doing this. So now what I'm going to do is I'm going to take off 1 carbon off the end, and now I'm going to try and put that 1 carbon in different spots. So let's see here. Let's number these guys. So this is the first one. So I'm going to take the carbon off of the end here. I'm going to take this one off, and then I'm going to have a 7 carbon chain. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Okay, so that's 7 carbons. And now if I put the carbon here, the one that I popped off the end, if I put it here, that carbon chain is still going to be 8 long. So I can only start putting the carbons on this one. Okay, on the second carbon in. Okay, so when I name these things, I name them kind of backwards. Okay, so the longest carbon chain here is heptane. That's heptane. So that means that I've named these 7 carbons, okay, the longest carbon chain there, heptane. And now I just need to name this single carbon group dangling off the longest carbon chain. And so that single carbon group, let's see, that's a meth 1 carbon, and it's a group, so it's YL. And then we're going to number this. We're going to number the carbons in order here, 1, 2, 3, 4, 5, 6, 7. And so we're going to number that 2-methyl heptane. Okay, now real quick, and this is what's going to make this video a little longer, what if I were to make this the longest carbon chain? Okay, so this is now the longest carbon chain, and by making that the longest carbon chain, let's see, now this is a 1-methyl group. So now look, this is 1, 2, 3, 4, 5, 6, 7. It's still a heptane, and then we go 1, 2. It's still a 2-methyl heptane. So if you know how to name things and know how to draw them, you should be able to get all the isomers. Now I get it. You know, it takes a little bit of practice, but we can still do it. Okay, so now let's do another one. Here's another 7 carbon chain. 1, 2, 3, 4, 5, 6, 7. And let's put the carbon here. Okay, and when we do that, let's see, the longest carbon chain again is 1, 2, 3, 4, 5, 6, 7. If we go here, it's only 6. If we go this way, it's only 4. So it's 7. So when we name a carbon chain, that's a heptane. Okay. And now we have to name this. And so it's a 1 carbon chain. So, and it's a 1 carbon group, so it's a methyl group. And we already have a methyl heptane. But what makes this one different from this one? It's that this one is connected on carbon number 3. So that's a 3-methyl heptane. Okay? So this is 1, 2, and then this is our third one. Okay? So let's do another one. 1, 2, 3, 4, 5, 6, 7. Okay? What if we put our 1 carbon chain here? Okay? And I'll number this one, or I'll do the name of this above it this time. So this is 1, 2, 3, 4, 5, 6, 7. Okay, the longest carbon chain is 7. So that's still going to be a heptane. Okay. Heptane. And so this is a 1 carbon group, methyl, and it's off of carbon 1, 2, 3, 4. So that's a 4-methyl heptane. Okay, so it's starting to go. Okay, we're starting to get somewhere. Okay, all of these will have the formula C8H18. And that's the wild part, is that when you think about your octane rating in your gasoline, octane is a combination of all of these different isomers here. It's not just this guy. Okay, actually, when we get to it, I'll show you what the most common the most common isomer is that's in gasoline. Let's see. So what if we do another heptane? Okay, and so we seem to be on a thing here. And so now this is where it gets tricky, because look, 1, 2, 3, 4, 5. People will want to call that 5-methyl heptane, but that is incorrect. Okay. Here's the way the numbering works, and I don't think I went into detail on this in the last video or even on these, is that you want to number your carbon chain, your longest carbon chain, starting from the side that is going to give you I just bit my tongue, giving you the least total of all the numbers added together. So we can name this 1, 2, 3, 4, 5-methyl heptane. Or if we start on this end, okay, if we start on going this way and we go 1, 2, 3, this is the same as 3-methyl heptane. Okay, which is interesting because that would be if you just take this guy and you just kind of flop him over, pick him up, and if you pick him up and turn him over, it's going to be the same as this. So this is kind of the end of all of the 7 carbon chains. So now what we can do is now we get into the 6 carbon chains. Let's pop off now a second carbon. And now this is 1, 2, 3, 4, 5, 6. And now let's start putting 2 carbon chains somewhere. So what if we do this? What if I put a carbon here and a carbon here? Okay, so now this gets into the naming using prefixes for the quantity as opposed to, and also naming in terms of numbers of them. Okay, in terms of the number of the chain. Okay, so again, longest carbon chain. Start with the longest carbon chain. That's going to be a hexane now. Okay, that's a hexane. And I always name these backwards. I start with the longest carbon chain and then name the groups. Okay, and now we have a 1 carbon chain here and a 1 carbon chain here. Do not get confused. This is not a 2 carbon chain. It's a single 1 carbon chain, and this is a single 1 carbon chain. And so we want to, I deleted that so I had a little bit of room here. So that is so how many 1 carbon chains are there? There's 2 of them. So this is a dimethyl hexane, meaning 2 methyl groups, which now we have named, okay, hexane, 6 carbons. So we have 8 carbons. Our name implies 8 carbons. Now we have to number where they are. And so we have to number each group, even though it may sound repetitive. We have one group coming off of the second carbon, and then we have a second methyl coming off of the second carbon. And so that's going to be 2,2-dimethylhexane. So if we number this 1, 2, that carbon 1 and 2, we're going to have one methyl group coming off of here, one methyl group coming off of here. So that's 2,2-dimethyl, 2 methyl groups, hexane, longest carbon chain. Okay, so now we're getting into some of the more interesting structures. So now let's do a 6th one. Okay, so again, we probably have a bunch of these with 6 carbons as our thing. So let's put a carbon here and here. Okay, now again, longest carbon chain, 6 carbons. Okay, longest carbon chain, 6 carbons. Okay, so that is a hexane. It's still a hexane. And then there's 2 carbons here. Sorry. Okay, that's a hexane. So let's put the carbons here. Okay, it's weird because it's at the bottom of the screen. Okay, and now how many methyl groups are there? There's 1 here, and there's 1 here. So that's going to, again, be 2 methyl groups, dimethyl hexane. And now instead of being 2, 2, which carbons are they on? They're on the second and the third, so that's 2, 3-dimethyl hexane. Okay, so now we're at 6. Okay, I'm going to take some of these, I'm going to erase some of these guys, because I want to be able to have some more room here. Okay, now let's do another one. Here's 7. Okay, so again, okay, 6. Okay, and so now we're going to put a carbon here. And what if we put a carbon here? Methyl, again, it's another 2-methyl chain. Now, let me use this as my example for how to number this. Okay, so let's first realize that that's a hexane. Okay, it's definitely a hexane. Now, if we started numbering from here, this is 1, 2, 3, 4, 5. So that would be 3, 5-dimethyl hexane. Okay, but if we start numbering from this end, 1, 2, 3, 4, that's going to be 2, 4-dimethylhexane. When you add up, when you add up those two numbers, which one gives you the smallest total number? This equals 8 added, and this equals 6 added, so it's going to be this way. So we want to number that this way. Okay, so that's another example of how we number so that we get the smallest total addition when we add the numbers together. And so again, we're going to name this and this. Okay, and so that is a dimethyl again. Dimethyl. I ran out of room a little bit there. And then it's going to be 2, 4 dash. Okay, 2, 4-dimethylhexane. Okay, let's do another one. Okay, we always separate numbers using commas and a number and a letter with a hyphen or a dash. Okay, again, systematic. It's one of the reasons why I like it. Okay, so now let's do this. 1, 2, 3, 4, 5, 6. Okay, good. Okay, so what if we do this? I don't know why my pen is doing that. I'm getting a little frustrated at it. Okay, but let's go like this and then like this. Okay, so again, I'm just kind of rearranging those two carbons kind of to make as many different combinations as I can. Okay, and so now this is a neat one because again, let's go like this. So that's 6 carbons. Notice if we go like this, that's also 6 carbons. Okay, well, so let's do this. So this is going to still be a hexane. how many methyl groups are there? There's 2, so it's going to be dimethyl. Di means 2-methyl. Okay. Guess if there's 3, guess what it's going to be called? Yep, trimethyl. If there's 4, tetramethyl. Okay, it goes on and on. Okay, but dimethyl, and then let's see here. It's on carbon 2, and then on carbon 5. So it's 2,5-dimethylhexane. Now this is kind of interesting. Excuse me, because again, if you number this way, you get 2, 3, 4, 5. You get 2,5-dimethylhexane. So in this case, this is a supersymmetric molecule. It's not really that special that it's supersymmetric, but at least, you know, in this case, it doesn't really matter which way you number it from. Okay. Okay, so we're almost halfway home. Okay. Now, I think that's all the 2-methyl things, but my guess is we can go, what if we have carbon 2, 3, 4, 5, 6. What if we do this and this? Okay. That'll be interesting. Now, again, hexane, longest carbon chain, 1, 2, 3, 4, 5, 6, hexane, and there's 2 methyl groups, so it's dimethyl, and this one is 3,3-dimethyl because it's on carbon 1, 2, 3 here, and you have 1 methyl group here, 1 methyl group there, and so now we've named all the carbons. We've named the hexane here, and we've named the methyl and the methyl, so for a total of 8. Okay, and again, just to reiterate the numbering, we're not going to number from this direction because it's 1, 2, 3, 4, and so what's lower? 3, 3 or 4, 4. 3, 3 is a total of 6. 4, 4 is a total of 4, 4 is a total of 8. So that doesn't help. Okay, so now let's look at another option. Okay, just like we did with the 2 dimethyls, okay, we can probably put one here and one here. Okay, so that's C, C, and so now we're halfway home, just so you know. We've hit 9 of these guys. Okay, and so again, 6, and then, okay, as long as carbon chain, so that's a hexane. And again, it's a dimethyl hexane. And now this is a 3,4-dimethyl hexane. Again, 1, 2, 3, 4, or if you start numbering on this side, 1, 2, 3, 4. Okay, so there we go. Okay, so that's 10. Maybe we can do an 11 down here. Okay, I think we are starting to run out of the dimethyls. Let's see. What if we did a 6-carbon chain? What if we did that? Okay, let's see. 1, 2, that would be 3, 5-dimethyl. But if we name from the other way, that's a 2, 4-dimethyl. And look, we already have 2, 4-dimethyl. So you have to be careful which way you run the carbons from. Okay, so I think that kind of exhausts all the dimethyls. But now we can do something kind of even more interesting. Whoa, hey, get back here. Okay, instead of having, what if I put both carbons on the same chain? Okay, so now again, what's our longest carbon chain? 6 carbons. That's a hexane. Okay, so that's a hexane. Okay, now we want to name a 2-carbon chain. Okay, well, what's the root number for 2 carbons? It's ethyl. Okay, so this is ethyl hexane. But we need to know what carbon it's coming off of. 1, 2, 3. So this is 3-ethyl hexane. Okay, a quick aside about 3-ethylhexane. You cannot take any ethyl group and put it on carbon 2, because by doing that, now you've increased the longest carbon chain by 1 when you do that. This is 1, 2, 3, 4, 5, 6, 7. That's the longest carbon chain, 7. And now you have a methyl group off of here. That's 3-methylheptane. You've already done that. Okay? So when you do this, okay, just like methyl groups have to go at least on the second carbon, ethyl groups have to go on the third carbon at least. Okay? So if we put it here, 1, 2, 3, it's going to be the same thing. So I think we are close to being done with the number of hexanes that we have. Okay, so let's get rid of some of these guys. And so now, if we're out of the hexanes, one of the things that I think we should do is, what if we do the pentanes? Okay, so the pentane, 12. Okay, so now how many carbons do we have to, can we plop around? We have 3 other carbons, because remember, all of these are structural isomers. They're all going to have 8 carbons, 18 hydrogens. Okay, and so what if I do something like this? Okay, now that's awfully whack. Okay, but let's do it up again. 1, 2, 3, 4, 5. Okay, that's a pentane. Now I want to name 1, 2, 3 methyls. So that's going to be trimethyl. That tells me that I want to put those 3 methyl groups someplace. And where am I going to put those 3 methyl groups? Carbon 2, and carbon 3, right? 2, 2, 3. So we have to put as many numbers as we have methyl groups. Okay? So we have 2 numbers here, we have dimethyl. We have 2 numbers here, we have di. Those have to be this, those have to correspond with each other. Oh, I'm going the wrong way. Somehow I hit the thing. Okay. So we're 2/3 of the way there. Okay. So what if we have another one of these guys? Okay. Okay. So now let's do 1, 2, like this. Okay. So again, longest carbon chain, 5 carbons, pentane. Okay. Now 1, 2, 3. There's 3 methyl groups, so that's going to be trimethyl. Okay, that's trimethyl, and now that's 2, 3, 4 trimethyl. Now, number from the other way, 1, 2, 3, 4, 5. It's still 2, 3, 4 trimethylpentane. Okay. So let's now get rid of some more of these over here. That was 13. Okay. That was 13 isomers. Okay. So now what about, let's do a 14 here. Okay. Again, I'm not sure we're done with this. Okay. What if we do with this? Okay. What if we do that? And now that is, again, okay, that's a pentane. And that is a trimethylpentane. But now instead of being 2, 2, 3, notice this is 2, 3, 3 trimethylpentane. 1, 2. You may want to be tempted to number it in the opposite direction. 1, 2, 3, 3, 4. 3, 3, 4, that adds up to 10. You go this way, it adds up to 8. 1, 2, 3, and then 3. So that is a 2. Name that carbon. Let me put the carbons on there. Okay. Name that carbon, that carbon, that carbon. So this is 2 is where that methyl is, and then 3,3 trimethyl. Okay. Excuse me. Okay. So this is where it gets kind of really frustrating for people. Okay. Because now we're going to do this. Okay. And now if we do this, some people are going to want to be like, well, what if I put this here? Okay. So now, no matter what, the longest carbon chain, no matter what we have, is going to be 5. Okay? So whether we go this way, whether we go this way, whether we go this way, it's 5. So watch how this is going to be named. And this is, again, some of this can be frustrating. Okay? But again, the longest carbon chain is pentane. Okay? By naming pentane, I got rid of those. And now on carbon 2, I have 2-methyl. Okay, and then on carbon 3, I have an ethyl. Okay, and I will tell you that there's a certain order that those should go in, but for now, I'm not going to worry about it. Okay, so we've named all 8 carbons: 3-ethyl, 2-methyl, pentane. 1 carbon here, 2 carbons there, 5 carbons there, for a total of 8 carbons. C8H18. Okay, so that's pretty cool. Now let's do number 16. Okay, I'm running out of room here, so let's get rid of these guys here. Okay. What if I said, hey, do this on a test? Okay. I probably wouldn't do that. Okay. 16. Okay. We're still in pentanes. 1, 2, 3, 4, 5, 6. So what if now we go like this? Okay. Now again, no matter what, we have a 5-carbon chain, pentane. Pentane. I don't know why my pen isn't writing. Okay. Pentane. And so now this is going to be 3. Okay, so now we need to do the methyl group. Methyl. And that's on carbon number 3. And then we need the ethyl. So that's on carbon number 2. So this is 2. Sorry, that's on carbon number 3. 3-ethyl, 3-methyl pentane. Cool, right? Okay. 2 more to go. Oh, okay. Oh. Oh, wow. Okay. So let's do number 17. Okay. Now, again, this is kind of where it gets hairy, because we may want to do, what if I did a carbon, and then a carbon, and a carbon? Okay. Well, that's going to be interesting. What is the longest carbon chain here? Okay. Well, it's 5, and then you have this stuff going on. Well, let me show you what goes on here. Okay. Watch this. How many carbons? 1, 2, 3, 4, 5. And then, again, we want the lowest total, not the lowest, when you add up the numbers, they get the same. So this is going to be 2, it's 2-methyl, 3-ethyl, pentane. Right? Because there's the ethyl group, there's the methyl group. And isn't that this same exact thing? Okay. Again, there's an order that these go in. So that can't be the one that we're talking about here. Okay. So, Okay. Well, let's do this. 1, 2, 3, 4. Now we have 4 carbons to pop off of here. 1, 2, 3, 4. That's the only place we can put all 4 of those carbons. Okay. Let me get rid of this for you. Okay. And now, let's name this. Longest carbon chain is 4. So now that's a butane. Okay. If that's a butane, now how many carbons? We have 1, 2, 3, 4 methyl groups there. So this is going to be a tetramethyl butane. And then if it's tetramethyl butane, well, now we have to put numbers there. And there has to be as many numbers as there are for that numeric prefix. Okay, so it's going to be 2, 2, 3, 3 tetramethyl butane. Now, here's what it is. Okay, I have done 17 of these things. I know that I've skipped one because I know that there are 18 of them. Okay, come to me with the extra one, and I bet you I can figure out some way to reward you for finding the 18th isomer of octane. Oh, and just so you know, this here is the most common isomer. No, that one's not. I was going to tell you which one, but I've already erased it. It's isooctane. It's 2,2,4 trimethyl pentane. Isooctane is the one. This is not the most common. Anyways, but I've done 18 of them, or 17 of them. If you figure out what the 18th one is, I bet you that I can come out with some sort of way to help you out. So feel free to pause, rewind, and have at it. Okay, have a lot of fun with this.